Hello class, welcome to 1.4 multiplying whole numbers. Our focus here would be on these objectives, to multiply whole numbers and looking at their notations. We'll also look at how to multiply a single digit and multiply by multiple digit numbers, and also of course look at the application of multiplying whole numbers. Okay. So when we talk about multiplying, we do have specific notations. So let's look at the notations here. So when we talk about multiplication, the symbol itself, like addition had a plus, subtraction had a minus, no confusion there, because it was just one way of expressing it. But when it comes to multiplication, we have different ways of expressing it. Okay. Now, what is multiplication? Multiplication is nothing but quick addition. Okay. So if you wanted to quickly add something, you do that. So we'll come back to the notations. So I will just say multiplication is quick addition of repeated numbers, right? So if I had to do 2 plus 2 plus 2, repeated numbers, I'm trying to add these numbers, this is the same as saying how many times do I add it? 3 times. And what am I adding? It's the 2. So 3 times 2. So 2 plus 2 plus 2 is 6. 3 times 2 is also 6. Okay. This is true for any repeated addition. So because of the quickness with which we can add multiple repeats through multiplication, we have also different types of expressions that come out of it. Now remember, we're learning this in terms of algebra. So if you were just looking at it from a very pre-algebra basic view, the x is the notation we've used, right? Times. But in view of algebra, we like to move away from x, because this x notation, because you already have an x. Now this is not the same as the x, but it appears very much like the x. And when we actually write it, instead of looking at it in a print format, when we write it, our x's and the multiplication symbol do not look any different. So for all these reasons, we'd like to remove or try not to use that times symbol. We also have the dot symbol, the dot to indicate multiplication. This is also frowned upon, because you have to plant that dot right in the middle. When you say 3 times 8, it has to be right in the middle. If it is lowered, it becomes a decimal point. It will become 3.8. And I, for one, have difficulty putting it right in the middle. It will somehow go lower in my case. So for all those reasons, I try not to use the times symbol or the dot symbol for multiplication. We prefer the parentheses. 3 times 8 is the 3 with the parentheses 8. It's a sophisticated version, and we actually lean towards this version of multiplication symbol because it is super helpful in algebra. It is a grouping symbol, the parentheses, so it really helps with all those grouping properties as well. And it really keeps it crisp without confusing it with any other similarly used symbols. Okay. So again, all these symbols mean the same thing. It means the product. So 3 times 8 is what it means in each case. And when we talk about the result, we say it is the product of 3 and 8. Okay. So no matter what symbol notation is used, these 3 symbols indicate multiplication. Now remember, we said multiplication is quick addition. Therefore, the properties that relate to addition also relate to multiplication. So we have the multiplication property of 0. Now notice how we spoke about the identity property, because the identity was preserved, and that was for addition. A plus 0 gave back an A. 0 plus A gave back an A. So the identity of A was not lost. Therefore, we called it the identity property of addition. That property is similarly used here, multiplication property of 0. However, the result is quite different. Okay. So let's play around with some examples here. So if I had 3, for the sake of this example, I'm going to use the dot symbol. 3 times 0. Okay. What is 3 times 0? It's not a 3 like you would have expected in the addition property. 3 plus 0 would be a 3. But 3 times 0 is actually a 0. You don't get back the 3. Instead, you get back the 0. 0 is the dominant result here. That's why it's called the multiplication property of 0. Likewise, 0 times 3 also gives back 0. Okay, maybe it works for 3 this way. What if it was 79? 79 times 0 is also 0. 79 times, or 0 times 79 is also 0. Let's test it with another number. 2. 2 times 0. 0 times 2 is also 0. Okay. What about 100? 100 times 0 is 0. 0 times 100 is also 0. Alright, so then we begin to see the pattern that no matter what the number is, small or big, when you multiply any number with a 0, it returns a 0. So as a way of generalizing, I say a times 0 is equal to 0 times a, right? So they both give you a 0. So a times 0 is 0 times a, which is 0. Okay. Now, what are the other ways I can express this? So I have a times 0 with the x symbol, so the times symbol, and have your a with a nice tail. And the third way of expressing this would be a times 0. We usually put the parentheses for the second term, or the second number, like this. Okay. In fact, as we move on, you will realize that it's not wrong to do even this. Meaning you put the parentheses around both these terms, numbers, that's totally fine. The norm is this, that we do one of them, but when we move deep into algebra, you'll feel more comfortable, more secure when you put the parentheses around the two expressions that you're trying to multiply, 2 or 3 or how many ever. Okay, so that is something that you want to get used to, the parentheses. So multiplication property of 0. Now we had the 0 in the addition was called the identity property because the identity wasn't lost. But then the 0 there did not lose the identity for the a that was added to it, but here the 0 made the result come back as 0. So then the question is there really an identity property for multiplication like how we had for addition? Meaning, is there something that when I multiply with it, it gives back that original number? Meaning, does it preserve the identity? And we see that, yes, there is such a number. So let's write the identity property of multiplication. It's very important to indicate for which operation we do this. Because the identity property for addition was a 0 that was added to that number, but here it's going to be something else. You probably guessed what it would be. It is 1. 1 times, say, 12. What is it? It's going to be a 12. Likewise, 12 times 1 is also a 12. Notice how the identity is preserved when I multiply by 1. Then let's go ahead and test it with other numbers. 1576. Well, if you look at the result, it does give us 1576. No matter what the number is, when you multiply it by 1, it gives back the same number. So the identity property for multiplication is related to 1, whereas the identity property for addition is related to 0. Okay, note that point. So 1 times a is the same as a times 1. Each time it gives back the identity of a. So if we want to again rewrite this with the other symbols, is a times 1 Now this parentheses, right? Now when we say 1 times a, you use the dot or the times symbol, right? When we have this parentheses, there's another way we also express it. We use the word of. Okay, to say instead of times, we also use alternately of as a replacement for times. So I'll just write here times of indicate, that means implies. When I use this symbol, it means implies. Times of implies multiplication. So if I say 1 of a of 1, you don't say that, it sounds a little odd, but when we come into word problems or other types of notations, then that of is what we use. Okay. Now in comparison with addition, there was one more property that worked for addition, the commutative property. Now notice that we didn't do such properties, or any property for that matter, for subtraction, because the order does matter. Remember, commutative means to commute, meaning go from one point to another point. So commutative property of multiplication also is the same thing, to go from point A to commute. Point A to point B is the same as point B to point A, to commute. Okay, so that means order does not matter because it's the same thing. So for that, again, if you think of numbers, 3 times 2 is 6. 2 times 3 is also 6. That's why the multiplication table actually, if you see, you have those repeats, right, for those numbers, because that's how it is arranged. So you can arrange 3 groups of 2 or 2 groups of 3. Okay? 3 groups of 2 or 2 groups of 3. Notice how I use the word of to indicate the multiplication, right? We didn't say that. So it just depends on how you express it. And the word of here indirectly kind of points to you that we're talking about multiplication. All right, so we have this. And is it true for any other number? Seven times 10, 70. 10 times 7, 70. Yes, it works for all of these things. So let's write a general rule then. The general rule will require two of them, A and a B. So A times B is the same as B times A. Notice how again I use the B as a cursive letter. Other notations are you always have to say what A and B represent, okay? A and B represent numbers. That's very important for us to understand why we chose A and B. Because it's nowhere defined, then it really doesn't tell us what we're doing here. What we're trying to do here is to see if we can use a generalization by using the letters to indicate this commutative property. How to multiply two numbers without using a calculator. So let's take this example. I'm sorry, I dropped my pen. All right, 15 times 4. So the book uses the dot symbol, so I'll just follow the book so that you're familiar with all these symbols. Again, remember, because it's pre-algebra, we're not so particular about which symbol you're using. It's just that in algebra, you yourself will realize that parentheses is the best option. Okay. So if you see me using more of parentheses or anything, it's just out of habit, and that habit is because of the preference that I had set for myself as I advanced into math, right? So it's something that I would like to encourage you to do as well. Alright, so to multiply these two numbers manually, we do just like how we did for addition and subtraction. We're going to arrange them vertically. Same style. You put the 4 underneath the 5 because there's just one digit there. Then put the star in case you want to keep that holder there. So 4 times 5 is 20. You should be pretty strong in your tables, okay? Because you're not supposed to use the calculator even for your tables. If you're not sure about your tables, it's good for you to go back, revisit, and memorize if needed. You know, if you're going to sit and count each time to know what the table is, that is going to drag time out of your actual math calculations, because very soon we'll be moving into more you know, elaborate calculations. So you really want to strengthen your table skills, and you should be able to have them in your fingertips, you know, to be able to compute these things more quickly. Alright, so I take this 4 and I multiply it to this and to this. Okay. Remember, this is multiplication, so here we use the X symbol. That's the best symbol to use when you are multiplying it vertically like this. And we typically do this kind of multiplying vertically only with numbers. So it really does not impact any other letter that you might be using. So that's why the X here is totally meaningful. So now here you have 4 times 1, because that's the operation. 4 times 1 is 4. Then what you carried on the top, you need to add it to it. So 4 times 1 is 4. 4 plus 2 is 6. Look at how that 6 didn't look right in the beginning. Alright, so watch out for your handwriting as well. And so I boxed the 60 to indicate that that's the answer. Okay. In fact, if you look at the ebook, it gives you all these explanations more in a more step-by-step manner, very detailed. Okay. So these are all when you multiply a number by a single digit. So let's do some more examples. Two, 8, 6 times 5. So what you do is you right away put it up or line them up vertically. 2, 8, give it more space if you need more space, times 5. So there is nothing but just the 5 to multiply this top row with. Okay, so you're going to go like this, then like this, and then like this. Always from right to the left. So 5 times 6, or 6 times, again commutative, so it doesn't matter. 6 times 5 is 30. Carry over the 3. 8 times 5 is 40. Add the 3 to it, 43. And carry over the 4. 5 times 2 is 10. 10 plus 4, 14. So your answer is 1430. So when you are ready to present your answer, remember that's when we want you to insert the comma in your final answer and box the answer when you show the written work. I'll do one more. Four, 6, 2 times 7. So 4, 6, 2 times 7. 7 times 2 is 14. Carry over 1. 7 times 6 is 42. Plus 1, 43. 7 times 4 is 28. Plus 4, 29, 30, 31, 32. And then you present your answer. 3, 2, 2, 3, 4. Box it. How about this one? This one says multiply and then 62 parentheses 87. You know that means multiplication, so line them up. 62 times 8, 7. So this is slightly different because now you have a 2-digit number that you're multiplying it by with. Therefore, we have to be extra careful. Okay, so I'm going to use color code to show you how we do this. Okay. So I take the 7, so you always start from the rightmost end to the left, right? So I take the 7 and I'm going to use that 7 to multiply the top row. So 7 times 2 is 14, carry over 1. 7 times 6 is 42, plus 1, 43. Okay. Then we move to 8. We move to 8, isn't it? So when we move to 8, what happens is you want to put a star underneath the 4 because that is the 7th position, right? That's where you started for 7. But you're starting for 8 here, which is one position, one place away. So you want to now do this, 8 times 2 and 8 times 6. So 8 times 2 is 16. So you put the 6 here under the 3, not under that 4. That's why I put that star to make sure that nothing goes there. 16. And I put a 1 here in green so that I know this is the one that counts, not the red one that counts, even though they both are 1. In this case, it was okay, but in a different case, you may not have anything to carry over, or you may have a different number, so it's good to identify it separately. 8 times 6 is 48 plus 1, 49. So please arrange them, line them up neatly, so that only the first position that you would have otherwise used is now taken up. And then you have, we call these the partial sum, okay, or partial products. Why? Because you did them in 2 rows, right? You did the multiplication. Product is another name for multiplication. So you did the 2 rows separately because you did 1 row of multiplication for the 7, another row of multiplication for the 8. For that 87, you split it up like that. Now you've got to add them. Okay, you have to add them. So 4, and that placeholder is a 0, right? Basically. So sometimes students just put a 0, which is totally fine. But I personally don't like the 0 because what if you had a 0 in the problem? You wouldn't be able to differentiate between this 0 and that 0. So we use the star. So we add it down. There's nothing to add. Star is nothing. So 4. 6 plus 3, 7, 8, 9. 9 plus 4, 10, 11, 12, 13. 4 plus 1, 5. 5, 3, 9, 4. So you see how we have the partial products in the end added together. So 62 times 87 is equal to 5,394. And that is the answer. Feeling a little adventurous? You should be, because we're going to now multiply 3, 5, 4, 4, 3, 8. Notice how we have the parentheses around the 2. It doesn't matter because we are quite clear about the role of that parentheses. Here it means to multiply. When you put in the vertical order, you do have the multiplication times symbol that kicks in. Okay, the rule hasn't changed. The rule will be that you now have 3 digits, so you're going to take them 1 digit at a time. So how many partial product rows will you have? You will have 3 rows for the 3 digits. 1 row for the 8, 1 for the 3, and 1 for the 4. And in the end, we'll be adding them together. So again, to help us out here, let me use the color code here. Okay, so that's what we're going to do. So 8 times 4, 32. 8 times 5, 40, 43. 8 times 3, 24, plus 4, 28. Space it out so you have enough room there. Then we go with the 3. Okay. I'll just say here it's a partial product for 8, right? That's what we did. We did it for 8. This time I'm using it for the 3. The 3 is in the middle row, so any answer should go under this one. So I'm going to put a star there to indicate that we're not using that spot. 3 times 4, 12, carry over 1. So I'm only focusing on the red. 3 times 5 is 15, plus the red 1 is 16. Here again I carry over a 1. 3 times 3 is 9. 9 plus 1 is 10. Ooh, okay. Notice how you are positioning them properly. That's super important. Then we choose the 4. And it's getting a little busy here. 4 is now to be multiplied. 4 is 2 spots away. So I do the star for the last 2 spots so that I'll start lining them up from here. 4 times 4 is 16, and that's the green one there for it. 4 times 5 is 20, plus the green one is 21 with a 2. 4 times 3 is 12. 12 plus 2, 14. Yeah. Alright, now we are supposed to add them. So the 2 comes down as it is. Here 3 and the 2 will add. There's nothing to add here. So 3 plus 2 is 5. 8 plus 6 is 14. 14 plus 6 is 20. The 2, carry over a 2. 2 plus 2 is 4, plus 1, 5. 4 plus 1, this column is 5 and a 1. Ooh, that's 155052. So I can conclude here that 354 times 438 is equal to 155052. Then I come back and insert the comma by grouping them in 3s. Okay? And so that will be the answer. You know, we had, she's no more. We had this great mathematical mind from India known as Shakuntala Devi. That was her name. And you can actually go back and look it up. She was known as human calculator, or human computer, I should say, because she was faster than the computer. So she came from a very, very humble village, and she just had an uncanny sense of how to quickly compute things, and she could do extremely complex calculations all in her mind's eye and give away the answers even as the question was being laid out. She could just write the answer in whatever order we wanted. If we wanted to go from left to right, she can say that. From right to left, she can say that. She's never once gone wrong. So it's amazing. It's amazing. I remember she once visited our school. I was too young, so I didn't really appreciate it. I really regret it now. But when I was studying in India, she's visited us once. So what I'm saying is, it's amazing how the human brain is so capable, so powerful, and so it's amazing how we were the ones who created the calculators and the computers. So don't ever think that you need a calculator to help you survive a math course. Okay, well, eventually we will be using calculators to speed up our calculations, but always rely and believe in your mind power, in your brain power, because you are far more superior than a calculator or a computer. Your brain can process things and can store things and can retrieve things much better and faster and more accurately than a computer or a calculator, because it gives back what you feed in. You know, there's a saying, garbage in, garbage out. So whatever you input is what it's going to use to produce the output. So if we don't, in fact, if you look at the calculator, it will say, these days it says domain error, syntax errors. You can actually tell that there was an error, whether it was our input error or if there was a domain error, which are a little advanced in math to understand the difference. But syntax error simply means that something was wrong in our entry. And so what I'm saying is, don't think this is all trivial. Why should I be doing this by hand when I have a calculator? I think this is a great time for us to put on a positive mindset and also recall those great minds and those great mathematicians who were instrumental in developing these calculators. So which means during their time, they did not have a calculator, and how they must have computed these complex information, and that was centuries ago. So if they can process these things so many centuries and eras ago, I'm sure we can totally get this, right? All right, class. So I will wind up with a word problem. Before we move on to the to an actual word problem, let's take a quick look at how to translate word phrases to math notations. And so we have these three commonly used phrases for multiplication. They can say simply multiply, but that's not always the case. You would hear the word times, product, twice, thrice, and so on. So you have 3 times 8, very straightforward, and they've given to you in those different notations. The product of 3 and 8. Here again, just like the sum of 3 and 8, the difference of 3 and 8, the product of 3 and 8, the order is to be preserved. Here commutative property allows you to switch the order, but as we mentioned before, we want to maintain the order as best as possible so that we don't have to keep remembering and unremembering some rules. It's better to apply them all. If they apply to them all equally, it's better to just do that. So the product of 3 and 8 is 3 times 8 with 3 first and 8 next, and you multiply them. Twice 4 means 2 times 4. Twice means 2 times. Thrice 4 means 3 times. Or triple, it just depends on what phrase it comes under. But just go by that hint there to know what to do with it. Here is our example. I think it's Humberto or Umberto. Okay. Bought 4 sheets of stamps. Each sheet had 20 stamps. How many stamps did Humberto buy? So the question here is, he bought 4 sheets of stamps and each sheet had 20 stamps. That's our biggest clue, right? So let's come over here and say, okay. So there were 4 sheets. So we're asked to find the total number of stamps. Here, when you see the word, the word total, it doesn't appear in the problem, but this is how we interpret it. So don't mix it up as, oh, I said the word total, so it must be addition. No. We're asked to see how many stamps did he buy. So we need to understand the background here, right? So there were 4 sheets of stamp, 20 stamps in 1 sheet. That right there, you can actually do this 20 plus 20. So the total is indirectly helping us because this is what you're doing. So this is sheet 1, sheet 2, sheet 3, and sheet 4. This is addition, but you know what multiplication does, right? It does quick addition of repeated numbers is what multiplication is. So you simply do 4 times 20, which is what you do vertically, 20 times 4. This is what I share with my children too. When you have something like this, when you have trailing zeros, you don't have any other number after the 0, okay? If you have trailing zeros, only zeros in the end, you can kind of ignore it and just do 4 times 2. 4 times 2 is 8, and you put the 0 next to it, the 0 that you didn't multiply. If you had 200 times 4, do the same thing. Ignore those 2, just do 4 times 2, 8, and then bring those 2 zeros. It will be 800. Okay. So if it is, say, 1200 times 4, again, ignore those 2 zeros. 4 times 2 is 8, 4 times 1 is 4, then add those 2 zeros in the end, right? So this will be a quick way for you to multiply when you have trailing zeros. Otherwise, can you imagine? In fact, if you were to do this like this, 0, 0, okay, 8, 4. Okay, this at least is not too bad. But imagine if you had 400. Okay, so you'll have one row of zeros and then another row of zeros. You have the star. So you can see how that's really, really too much. Instead, just do 12 times 4 is 48. 1, 2, 3, 4. Add all the 4 zeros. And then go back and put the comma. Okay, so these are quick ways or tips or tricks. I encourage you to look at some free videos in Rumble or in YouTube or whatever site you visit. And you can get that information there where they share many tips and tricks for quick calculations. All right, so you come back here and you, because it's a word problem, we're going to come back and say Umberto bought 80 stamps in total. Or you can skip the word in total because it wasn't there in the problem. But 80 is the numerical value and stamps is the measure, the unit of measure, right? We're saying what it is. 80 what? 80 stamps. Let's look at this example. When Rena cooks rice, she uses twice as much water as rice. How much water does she need to cook 4 cups of rice? You probably do this at home. I have stopped measuring all those things. I just eyeball the measurement. That's why sometimes my rice gets overcooked, and so I quickly change my recipe so that it goes with some curry, so that the overcooked nature of my rice is not detected so quickly. But what I'm saying is we always like to do things in a measured manner when we are following recipes, and particularly when we're cooking for somebody else, right? If there's a visitor or a guest, then we're extra careful and we are particular about the measurements. And so I've seen this really, really important factor in baking, because when you cook over the stove, it seems like you can adjust or at least you can monitor what's happening and you can control it. But when it's baking, you know, it is you can't keep prodding it, and if you keep opening and closing the oven, often you'll be missing out. So I always am a little more cautious and watch my measurements when I bake rather than when I cook over the stove. All right, coming back to the problem. So she uses twice as much water as rice, right? So if there is, so how do you understand this? So which is more? She uses more rice than water or more water than rice? So she uses twice as much water as rice, which means the rice is less and the water is twice as much, 2 times the rice. Right? Now, how much water does she need to cook 4 cups of rice? So once you get the understanding from the first sentence, then you can come over here and begin to write it out in words and then translate it. So I'll say twice as much as 4 cups, right? So whatever she has, 4 cups of rice. So whatever she has, she needs twice as much. So that will be 2 times how many ever cups? If there's only 1 cup of rice, then she needs 2 times that much water. If there are 3 cups of rice, 2 times 3. Here it is 4 cups of rice, so it's going to be 2 times 4, which is 8. So you'll say Rena needs 8 cups of water for 4 cups of rice. And this is your answer. You really need to measure 8 cups. Okay. All right, class. So that's pretty much it. And have fun doing the exercise problems. These are, again, very simple, but you can finish them pretty quickly. And if you do finish them quickly, feel free to move on to the next lesson or the next lecture and start preparing by looking at all the problems you've done in the previous week, the current week, and then prepare for an upcoming chapter exam or so, whatever is coming up. So watch out for all those. And if you have enough time at hand, do not waste it. Just try to move ahead in the course. All right, then I will see you in the next one. Bye.